Number theory is a branch of math devoted to the study of integers. It focuses on the properties of integers and finding patterns between them.
Modern number theory was created by Pierre de Fermat. Most of his theorems were communicated via letters to his friends, and few proofs have survived, though he claims that he proved all of his theorems.
One example of the number theory is prime numbers. Prime numbers are numbers that can only be divided by themselves and 1. Some examples are 2, 3, 5, 7, 11, 13, and 17.
Another pattern demonstrated by number theory are square numbers. A square number is a number that is the product of an integer multiplied by itself. Some examples are 1, 4, 9, 16, 25, 36, and 49. Square numbers can also be arranged into a square.
A third pattern demonstrated by the number theory are triangular numbers. Triangular numbers are numbers that can be formed into equilateral triangles. Some of these numbers are 3, 6, 10, 15, 21, 28, and 36.
Pythagorean triples are 3 numbers for the side lengths of a right triangle that fit the rule a squared plus b squared equals c squared, which is the Pythagorean theorem. Some examples are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Here we proved that 3, 4, and 5 are a Pythagorean triple. 3 squared plus 4 squared would have to equal 5 squared. 9 plus 16 would need to equal 25, which means 25 does equal 25.
Some questions that the number theory can answer are there infinitely many prime numbers? Can the sum of 2 cubes be a cube? Can the sum of 2 squares be a square?
One question, are there infinitely many prime numbers, was answered by mathematician Euclid. He said that yes, for every list of prime numbers you come up with, there is a prime number not on the list. Given the equation, capital P equals P1 times P2 times all of the prime numbers you can come up with, P is equal to the product of that. There's also Q equals the product of all the prime numbers you come up with plus 1. If Q was prime, then all the prime numbers you came up with plus 1 equaled a new prime number that was not on your list. If Q was not prime, then there's some prime factor that could divide Q. If the factor were on our list, then it would divide the product of all the prime numbers, but it would have to divide all the products plus 1. If the new number divides all the products plus 1 and Q, then it would have to divide the difference. This would just end up equaling 1. No prime number can divide 1, so P cannot already be on the list. This is how we know that for every prime number you can come up with on a list, there's a prime number that you didn't come up with.
The number theory is very important because it helps discover new number patterns. You can use those new number patterns to help relate all the numbers that you know of to each other.
This helps us understand lots of the patterns that we find in math all the time.
Every day.